When we use water, it becomes wastewater. We cannot dispose wastewater into the environment because it creates pollution. Hence, we need to clean the wastewater. How to clean the wastewater? It is in a small scale. For example, water coming from our houses, hospitals, school hostels, office. Here we can see the constructed wetland, which works as a mimic of the natural wetland. When wastewater is passed through these media, the organics and other contaminants are retained. The filter media and the root of these plants work as a working site for the bacteria, which decomposes the organic materials. These plants also provide oxygen for the aerobic decomposition. Plants also consume carbon and nutrients. When we harvest these plants, permanently remove water flow horizontally from the inlet to outlet. The bed is constructed over the compacted clay, and we can also construct a wall, and this bed is filled up with the sand media of 3 to 6 mm size. We can also use cross stone of the similar size. Inlet and outlet zones are filled up with large size boulders for the distribution and collection of the water. The water is distributed throughout the bed using the perforated pipes. So we can plant the reed at the top surface at the distance of 1 to 1.5 meter. When it is fully grown, it covers the area. A standing pipe in the outlet is connected to outlet pipe from the bed with a swiveling elbow. In the beginning, this remains in the standing position. After some time, voids in the media gets clogged, and there will be more and more head loss. In that case, we need to tilt this standing pipe down. When it is fully tilted down and water appears in the surface, that indicates we need to remove the media and clean it and replace it. Cleaning time may last up to 5 years. So here we can see how this media is filled in the bed. This perforated pipe in the middle of the bed is for taking the water sample, especially for the research purpose. Now let us discuss how to calculate required area of reed bed. Here we use first order kinetics for the BOD reduction. We can derive and simplify this equation. The natural log of ratio of influent and effluent BOD is equal to reaction rate and the detention time. As we know that this detention time is related to discharge of wastewater and the volume of the bed. Using this simple formula, we can directly calculate required area. Let us take a design example of horizontal reed bed system. We can consider a school hostel with 100 students using 60 liters of water every day. If we assume the 80% of the water is wastewater and it becomes 4.8 meter cube every day. Assume that influent BOD is 200 milligram per liter and the effluent standard is 30 milligram per liter. So assuming the depth of reed bed is half meter, the area required comes out to be 28 meter square. And we can provide the 3 beds of the 2 meter wide and 5 meter long. So for every student, we need the 0.3 meter square of constructed wetland. Clear water is flowing from all the beds. I hope you have now some idea on how to construct reed bed for the treatment of wastewater. This plant looks so natural and the treated water is so clean. We can dispose this treated water in the natural water body, or we can reuse this because still it contains some nutrients. We can use treated water for irrigating vegetables in our gardens. So if you have idea, you can also mix up this water with urine, replacing the chemical fertilizer. You can grow more and more vegetables using the drip irrigation system that consumes very minimum water. Thank you.